Now let's talk about the chain rule. It's maybe the most complicated rule for students, and we pay more attention to it. First of all, we should define the composite function. What is this? Composite function is a function of one or more independent variables, at least one of which is itself a function of one or more other independent variables. So, simply, it's a function of a function. What is the chain rule? If we need to find derivative of the function f, which is composite function, means that it is the function at least of one more function, or function g, we have two functions here. Can be more, but in our example we have two. Function g is inside, function f is outside function. And what we do? We find derivative of the outside function and we multiply into derivative of the inside function. So f is outside, g is inside, and we find derivative of each of these functions and the product of these derivatives. Let's cover some examples. The first is a very simple example. We have the function sine x cubed. Here you see that it's not a simple function because the simple function is sine x or x cubed, but this is composite functions. It consists of two functions, sine and function x cubed. Actually, we can put parentheses here to see that x cubed is function inside, the sine is outside function. So this is inside, sine is outside function. How to find the derivative? According to the rule, derivative of the outside function is derivative of sine. Derivative of sine is cosine, but cosine of x cubed, because the x cubed is angle in this case, or generally it's the argument, and we cannot change it when we find derivative. Function was sine of x cubed, derivative is cosine of the same argument of the x cubed. And then we should multiply by the derivative of the inside function. The inside function is x cubed. So what we get? We get cosine of x cubed multiplied it by 3x squared. So here we have derivative of outside function, here we have derivative of inside function. Sometimes to solve such examples we can use this substitution. So for the same function sine x cubed, if we substitute x cubed by u, we can rewrite sine x cubed as the sine u. And to find derivative of the sine u, derivative of the sine is cosine, and multiply by derivative of u, because u is not the argument, is also the function of x. And the same, if we substitute back x cubed into u, we have cosine x cubed multiplied by derivative of x cubed. Actually we get the same, cosine x cubed into 3x squared. I think the first way is the simplest, and we will use this to find the second derivative. The second function is similar but different, is sine cube of x. We can rewrite it. We can write it as sine x raised to the third power. It's the same. But now we can see that in this case, sine x is the function inside. power is the outside function. If we'd like to compute this function, firstly we compute sine, then rise to the third power. So sine x inside, the power is outside function. And remember, when we need to find, if we want to find the derivative of the power function, we use the power rule, we will get 3u squared, but if u is the function of another argument, we should find the derivative of it. So according to our rule, we will get 3 sine squared x and multiply by derivative inside function. So derivative of sine, we will get 3 sine squared x into cosine x. One more example. We have function e raised to the 3x power. Here what we have, 3x is inside, e is outside function. Derivative of outside function is the same, e to the 3x power, because derivative of the e function is the same, and argument is the same too. And multiply by derivative of 3x. So what we get? We get e to the power 3x times 3. One more example, a little bit complicated. What if we have logarithm, natural logarithm of the logarithm natural of x? Here we have what we have. We have two logarithms, but one of these is inside, another is outside. Remember that derivative of logarithm of x is 1 by x, but we have logarithm of logarithm, so derivative outside function gives us 1, our logarithm x, and multiply by derivative of internal function. We have 1, our logarithm x, into 1 by x, or simply 1 our x logarithm x. And let's try more examples. The next function is x squared minus 3 raised to the 5th power. And again, the function in brackets is the inside function. Function out brackets is outside. That's simply to remember. So the power rule gives us 5 x squared minus 3 raised to the 4th power multiplied by derivative of the inside function. Derivative of inside function gives us simply 2x. Remember, derivative of negative 3 is 0. And we can multiply 5 times 2 is 10x, x squared minus 3 raised to the 4th power. One more example. Here we have the root of x squared plus 2x. Before we find derivative, we can simplify it. We can rewrite it as x squared plus 2x raised to the 1 over 2 power and derivative. Again, we use the power rule. We have 1 over 2 x squared plus 2x. 1 over 2 minus 1 is negative half. And multiply by derivative of the x internal function. And what we get? Here we can rewrite it a bit. We can move this term x squared plus 2x to denominator and rewrite it in radical form. What we have? We have 1 over 2 square root of x squared plus 2x, and derivative of x squared plus 2x is 2x plus 2. Or we can write it like 2x plus 2 divided by 2 square root of x squared plus 2x. And we can simply cancel 2. Here we have 2, we can cancel it. And what we get? We get x plus 1 divided by root of x squared plus 2x. Let's try one more example, but in this case we consider much complicated function. Actually, function which is the function of two functions. So we have not two but three, composite function of three functions. What we have? We have a logarithm of 5x plus 1 and logarithm is squared. We can rewrite this function to see more clearly what function is inside, what is outside. When we rewrite, you can see that we have three functions. The inside function is 5x, outside with respect to this inside function is 2, second function is logarithm, and the third function is the power. But as it's called the chain rule, we should do it like step by step. First of all, derivative of the third function, the function outside function. It's the power function. As x squared gives us derivative to x, so logarithm squared gives us 2 logarithms. 2 logarithm 5x plus 1. And then we go to the second function. Second function is logarithm. As derivative of logarithm, natural logarithm is 1 by x, but we have 1 by 5x plus 1. And the last step, derivative of the 5x plus 1 is simply 5. So here we found derivatives of the first integral function, then the second, and this is derivative of the external or outside function. If we rewrite, we will get 2 times 5 is 10 over 5x plus 1 logarithm of 5x plus 1. Let's consider one more example. When we have three functions in chain, it's function sine of tangent x cube. You may see that we have again three functions. Outside is sine, inside function with respect to sine is tangent, and inside function to tangent is x cube. Step by step, derivative of sine is cosine. Cosine as the same with the same argument with the same angle. Then multiply by derivative of tangent. Derivative of tangent is 1 divided by cosine squared of the same argument, and multiply by derivative of inside function is 3x squared. Let's consider one more example, but this example you'll see this is a combination of few rules. So what we have tangent squared of x plus e to the power x squared plus 4. What we have? We should apply the sum rule because we have the sum of two functions, but not simple functions, but composite functions. The sum of two composite functions. The first composite function is tangent squared x. The second is e raised to the power x squared plus 4. Derivative of tangent squared x is 2 tangent x multiplied by derivative of tangent is 1 over cosine squared of x. This is derivative of the first function, composite function, and derivative of the second. Derivative of e is always e of the same argument, but derivative of inside function, means derivative of x squared plus 4, is simply 2x. And one more example is sine cube x times cosine of x over 3. So what we have here? Here we have the product of two functions, again of two composite functions. And we should use the product rule. Let's recall that product rule is derivative of u into v is u prime v plus u v prime. Here we have u, v, and each of these functions is composite function. Derivative of the first part, derivative of u, is 3 sine squared x, and multiplied by derivative of sine is cosine x. And this multiplied it by v. So cosine of x by 3 is the same. Then plus function u, the first part the same, it's sine cube of x, multiplied it by derivative of the cosine x by 3. So derivative of outside function, derivative of cosine is minus sine of the same argument, multiplied it by derivative inside function, derivative of x over 3, derivative of x is 1, so we just get 1 over 3. So we can rewrite a bit to get the final answer. The first term is the same. Here we have plus and minus, so positive sine squared x by negative term, we will get minus sine cube x into sine x over 3 and 1 over 3 here. Here we have the final answer. So we have considered already, we considered all rules necessary to prepare for practical lesson and to prepare for the control work. So thank you for your attention and good luck.